Today we're going to look at SQL, particularly in relating to the tables. We talked a little bit about SQL last time, but we didn't really talk too much about tables. We're going to use SQL commands that allow us to create tables. And so in order to create tables, we'll have to know about how we structure the tables so we can write the create command. There's a special command in SQL called the create table create or create table. We're going to view the data that's in tables using, we're not going to do it so much as we'll look at the command, which is a select command. It's probably the most common command that we use in SQL. Correcting errors in the table using update command, saving SQL to a file that's what we call scripting, which is very useful in computing because once you get you know that you've got a command correct the way that you want it, you save that command in a script file, and then you can reuse it over and over again without having to rewrite it. We're going to use describe to look at the structure of a table that's already been created. So SQL stands for Structured Query Language, developed in the 1970s. The whole theory behind it for relational databases was only developed in the 1970s. So they got onto that pretty quickly. Once they developed the theory, then the practical came pretty quickly after that. It is the, I guess you could say, the query language of choice for relational database management systems, and that's what the DBMS stands for, Database Management System. So if we're going to use SQL, it's good to know the terms that we use. We refer to things like fields, records, and columns. Well, a column, you'll notice here, is talking about a field anyways. So a field is going to relate to an attribute of an entity. Fields, for example, if you had a customer table, fields would be things like customer number, name, etc. Things that we store data, the data that we store about customers. Each of those could be a field in the customer table. A record would be an individual row in the table. So for a customer table, the record would be for a single customer, all their details, their customer number, their customer name, street, etc. That would be a record. A column would be if you had all of the values for the street for all of the customers. That would be a column. And we use columns with SQL commands, query commands. So we use these terms: entity, relationship. Actually, part of the theory of relational databases is based on the idea of entity relationship modeling. So what one does is one identifies all the entities, identifies all their attributes, identifies all the relationships between them, then produces the keys, and from that we're able to develop the tables that you'll use in your database. Entity relationship modeling, if you want to look into that, just use that as your keywords for searching on it. So that, what I just said, is sort of said here in different words. But when we want to develop design a database, what we'll do is we'll find out what are all our entities, what they are, what is the data that we want to store about them. That would be their attributes. One of those attributes will be a primary or a unique field. And then any relationships between those entities, that entity and other entities, that will be important in how we where we place our foreign keys and our so the relationship is actually made by using foreign keys and primary keys and setting them to each other. The next couple of slides are about creating a table in an SQL database. We need to be able to define the types of data in each field. And so, for example, these are some of the data types that are used in SQL tables. So you have char, which is just a string of characters with a number length applied to them. Varchar is similar to char, but the number for the varchar is going to be the maximum length. So varchar is a little bit better for storage if you're worried about that, and you are worried about that if you're using database systems that have millions of records, which is quite possible. I mean, maybe you have a national health system or something like that. You're going to have millions of records in that. And so varchar is used to save space because, for example, if you've set, and that's all described there, but I'm just using slightly different words. But if you set a field so that it has a maximum value of, say, 60 characters, and then you put a number in, a name which has only got 4 letters in it, then with the char field that would hold that all 60 characters would have to be saved. 60 spaces would be used in the database whatever storage was used. But if it was varchar, then you you would only store the data that you actually put in. Those 4 characters would be the only thing that would be stored. Date is a special type of data type. And that's important that it is entered in correctly, because we can do date calculations, very important in many sort of business applications to calculate dates. And we talked about that with Excel. Here's some other data types which relate to numbers, various different numbers, decimal number. So we can use how long is the decimal in how many places it can have would be the P, and the Q, how many of those places could be after the decimal place. The int and the small int are for numbers without decimal places. Small int takes up a lot less space, but it holds numbers which are potentially a lot smaller, only up to 33,000. So that's only for small numbers, but it takes a lot less space to store it. Null, the idea of a null is, could you have a record which one field in the record had no value entered? That would be referred to as a null. Now, as it says here, there's some places where you mustn't allow nulls to happen. So, for example, every record must have a unique primary key, and so that is not allowed to be null. So, for example, there's other fields that you wouldn't allow to be null either. If you had a customer table, the customer number couldn't be null because that's a primary key. But you wouldn't also allow their name to be null. All right, but maybe you'd allow their postcode to be null. Because maybe you can identify where they live without their postcode. But their name, there's certain things, you use your common sense in that. But absolutely, you can't allow the key field to be null. Otherwise, it's not a record. It can't exist. It basically breaks the rules of a database. And so, if we want to force that rule onto our table when we're creating our table, we can use a not null class when we're creating that field in the create table. So we'll see a create table command in a minute, and the create table command is going to have listed a bunch of fields that go with that table, and we can the default is that if you didn't say whether it's null or not, the default will be that you're allowing nulls. But so if you don't want to allow nulls, you have to actually say not null. And so here is that example that we're talking about here. This is the create table command, and how you could read this and what it means is we're going to create a table. The name of the table is going to be rep. Notice we open a round bracket here and we close that round bracket there. And what's in between those two brackets is a list of all of the fields that are going to make up that table. So the first field is going to be called rep num, and it's going to be a character field. It's going to take up 5 spaces, and it's going to be the primary key. Now, because it's a primary key, that will not allow nulls just by virtue of being the primary key. But these other ones, it wouldn't be wrong to include there before the comma that not null. But because it's a primary key, I guess that's implied. Last name is a character field, which is going to hold exactly 15 characters. Anything less than that, it's still going to hold 15 characters, right? If we wanted to make this save space, we would change those chars to varchars. And it's not null. In other words, we can't have a a rep without them having a last name, and they also have to have a first name. However, if we look at these other things, the street and the city and the state, we are not setting them as not null, so it is allowed that we could skip the name of the street or whatever. Those things would be all right, because we are allowing null values. So create table command is used to create a table. We say the name of the table, and then we define each of the fields in the table, including, very importantly, the primary key. Um, Names of a table cannot exceed 30 characters. Not sure why that is, but I suspect it may be a limitation that was originally put into SQL because of it being used on Unix systems, that type of thing. It must start with a letter. In other words, you can't start the name of a table with a number, and that kind of thing should be familiar to you because it's also that way with some. Somebody's trying to chat with me. For some reason, it's kind of slippery. I can't open the chat. Well, it must be because of the table. So I have to wait until I'm finished the slideshow, if you don't mind, and then I'll look at the chats. But you can unmute if you have a question. Names cannot. Okay, so cannot have spaces. Those kind of rules, they should be familiar to you. They come up with other computer programming languages as well. Can't start a variable name with a number. You can't start a table name with a number. Here's a create command. Again, this one is the one we just looked at, isn't it? So there it is again, just showing it. Important, all SQL commands must have a semicolon at the end. It's not a correct SQL command unless it has a semicolon at the end. There says that they're free format. I think what it means by that free format is that it's you can put the fields in as you like. Of course, the order that you put them in is the order that they will show up in the table. And there it is again. When you run the command, and so when you're using your SQL and you enter your command, you will get a result come up to tell you that that command has been successful or not. So describe table, we can say just and show columns will allow us to see the table that we've already created. So we don't just say describe, we say describe what? Describe rep, describe the table rep. And what that will do is it'll show you all of the fields in the table, and it will show you the rules that are applied to each of those fields. So we can see which one is the primary key and that type of thing. We can drop a table. Now, this you will actually do a lot more than you think, because if you start using scripting. So very common for people to save a lot of data, and you can do that. You can write your data out of a table into a text file, and then you can use a create table and a bunch of inserts to recreate that table. Because actually a single insert, you can basically just build up an entire table from a text file. So that's kind of a common thing to do. And if you were going to do that, you can drop a table and then create it again and then insert all the data again fairly easily using scripts. So scripts are kind of cool. And hopefully you will show some interest in scripts, and maybe we'll start writing some scripts. So what would this do? Drop table customer. The table customer would be deleted from the database, and all the data in it would be gone. So what we would do before we did that is we would export all that data out into a text file. If you've got a table and you've created it, the moment after you've created it, it's just an empty table with nothing in it. So you have to populate it with data, and we use the insert command to do that. So the insert command, you can insert row at a time, or you can insert a bunch of rows. So how does it work? We say insert into, and then you give the name of the table, and then after that you're going to do values, and you'll now the values, you can say some of the fields or all of the fields. If you don't say so it could be that, for example, you want to insert fields, sorry, records that have some null values, in which case you want to say that you're going to insert the data in this field, but not that field. And so you can just skip the field out in the values part of it. Do we have an example? Yes, here we do. Insert into rep values. This is for a single record. And so the first thing there, notice they didn't say which fields. This one here is going to insert into every field in the table. So every field in that table is represented by this command. All we did is say insert into rep and then the values that are going to go for it. Now notice that we've got a round bracket there, a round bracket there. That is all the values are between those brackets, and a semicolon at the end is required for every SQL command. So insert command can be used um, one record at a time. It can also be used for multiple records together in a big insert. But look at this one here. This one is a little different than the previous insert command. Here we are giving a list of the fields that we want to insert data into. In the previous command, we just said insert into rep, and then we had the values. Here we're saying which fields. We're not, notice that this is a smaller insert command. We're not inserting every record. Sorry, it's a single record. We're not inserting every field in that record. We're only inserting 3 of the fields. Now, this would only work if the other fields were allowed to be null, because they are null. They're going to have null values because we haven't said that we're going to insert them. Now, the default, if we didn't list the fields that we're going to insert into, the default would have been the previous thing that we did. The previous thing that we did was see, insert into with no list of fields. Then we had to put a value in every one of those fields. And so this one is inserting a record into the same table, but not all the fields are having data inserted into them. Once you've got your data into your table, you can look at it, retrieve data using the select command. And so the select command has a certain way that it must be written. It's always like this: select. Now the star there represents a wildcard. Star just means all. But what we would put if we didn't want to get all of the fields, we put here the list of fields that we want to select from the table. So we say select the list of fields, then we say from, and then we have to have the name of the table. That is the minimum for a select command. Then you can have a where, and then after the where you can have a clause which sets some filters so that we only display some of the records according to some rules. So this is the very, very simplest SQL select command. Select all the fields from the rep table. And that's what this would give you, all the records and all the fields, because there's no filter. The filter applies to what records are going to be shown, and there is no where here. So this is going to give all the records and all of the fields of all of the records. And so that's one way of showing everything that's in a table. Update command, if you need to update, obviously. So you use update with a set attribute with it. And what that will do is it will change the value in a particular record to the updated value. So it is different than insert. We've also got another thing there, which is the delete, which allows us to delete a particular record depending on some delete is going to be used with a where. So we delete, unless you want to delete all the records, which you probably don't want to do. There's a better way of doing that anyways. So here we have a update command. So we're updating the rep table. We're setting the last name. So the only thing we're doing is we're changing one field in one record. We're changing that value. Now, which one record? The record where the rep number, and rep number is a unique identifier. That's how I know it's only one record. If we used some other where clause, something to do with maybe their address, maybe there's multiple records that had the same address, then so update can work with multiple records. In this case, it's only working with one record because it's where our filter is based on a unique identifier, their rep number. So what this is going to do is the record which has the rep number of 85, the last name is going to be changed to Perry. Maybe somebody got married. Sometimes people change their name for that. Yeah, so there it is there. This is just the easiest way of looking at all the data in a table. Select star, select all the fields from the table, and give all of the records. So the delete, it kind of looks like a select, right? It's got the same thing, from and where, right? Delete from the rep record where a particular thing. So what this is going to do is the record for rep number 85, the entire record, not just their rep number, the entire record will be deleted when their rep number is 85. So that is one of the records. So these are the things that we talked about. We create a table, which quite a big command, and that's how we go about sort of building our database, one create table record at a time. We create tables and then we insert all the data to them. We drop tables from time to time, and then we might have drop tables often followed by a create table command, because what we'll do is we'll drop a table and create it again with some changes. The data types are mentioned here. Remember that varchar is the same as char, except for the data. We don't store any empty spaces in the data, so it uses up less space on the hard drives, etc. Data is a special, it's almost like a numeric thing. We can do additions and subtractions from it. So decimal int and small int are number values. And depending on which version of SQL you're using, you can have date time or date. They're kind of the same thing. We use null values sometimes. We will set it so that nulls are not allowed in certain circumstances. Primary keys are nulls by default are not allowed. Select command is used to view data in a database. Update command to update it. We can delete an entire row using the delete command, or we could delete multiple rows as long as they met the criteria in the where. SQL commands can be written to a script file. So all of these commands that we talked about there, the create tables, typically we'll do that. We'll write the create table command and we'll save it into a file. And we can have multiple commands one after another in a file. And so you could create a database using those type of things all on one record, on one file. And then we could just run the file and all the SQL commands will happen one after another. That's what we call a script. Okay. So for example, here's two SQL commands. We know the two SQL commands. The end of the command is when you see a semicolon. And what is happening here is we create a table here in this create table command. Then immediately after that, we insert into that that table one bit of data. Yeah. Alter table allows you to change the structure of the table. That's quite different than update, right? You should remember and know the difference between update and alter. Update, we're not changing the structure of the table, but we're just changing the data in a particular, I'm going to say row, but it could be multiple rows as long as they met the criteria to find that row. So we can change everybody's name or a person's name. Alter table actually changes the structure of the table if you wanted to add a new field. or something like that. And so here's a bunch of commands that are mentioned. Now, before we talked about delete, and there's one command that we haven't mentioned here, which is the truncate table. Truncate table is kind of like delete, except it's going to delete all the records. Delete is going to delete a particular record depending on the where clause. And that is the lesson there. I hope that made sense to you.